Hello everyone, I am Digambaru Fade. Today we are going to study the new distribution, that is discrete uniform distribution. The title of today's lecture is Discrete Uniform Distribution. The definition of this distribution is a discrete random discrete random variable capital X is said to follow discrete uniform distribution if its PMF, that is probability mass function, is given by probability of x is equal to x is 1 by n. X takes values 1, 2, 3 dash up to n. The example of discrete uniform distribution is through a die. So it takes values 1, 2, 3 up to 6 and each having probability 1 by 6. The mean of this distribution is expectation of x, which is equal to summation over x takes values 1 to n x into probability of x is equal to x. In the first step, we put the value of probability of x is equal to x, that is PMF. So x into 1 by n. So 1 by n is constant. We take outside the summation. What is remaining inside? By putting x is equal to 1, we get 1 plus 2 plus dash up to last is n. You know the addition of first n, formula for addition of first n natural numbers, that is n into n plus 1 divided by 2. So this n gets cancelled. What is remaining? N plus 1 by 2. So mean of this distribution, that is expectation of x, is n plus 1 by 2. Then we calculate the variance of this discrete uniform distribution. Variance has the formula v of x is equal to expectation of x minus expectation of x whole bracket square. And to calculate, we use the formula expectation of x square minus expectation of x whole bracket square. So here expectation of x square already we calculated. So we have to calculate expectation of x square. So here expectation of x square has the formula x summation over x taking values 1 to n x square into probability of x is equal to x. In the first step, we put the value of probability of x is equal to x, that is PMF 1 by n. Then 1 by n is constant. We take out this outside the summation. What is remaining? 1 square plus 2 square plus dash up to plus n square. We know the formula for addition of squares of first n natural number, that is n into n plus 1 into 2n plus 1 divided by 6. So finally we get n gets cancelled, n plus 1 into 2n plus 1 divided by 6. This is the answer of which term? Expectation of x square. But we are interested in variance of x. Variance of x has the formula expectation of x square minus expectation of x whole bracket square. So expectation of x square already we calculated here, that is n plus 1 into 2n plus 1 divided by 6. We write as a 2 into 3 minus expectation of x square we calculated here, that is n plus 1 by 2 and bracket square. So we can take n plus 1 by 2 common. Now what is remaining? 2n plus 1 by 3 and 1n plus 1 by 2 will be remaining. And if you subtract these two terms, so first is n plus 1 by 2 as it is. What is remaining? By subtracting, we get 4n plus 2 minus 3n minus 3 upon 2. 3 into 2 is 6, which is equal to n plus 1 by 2 as it is. 4n minus 3n is n, 2 minus 3 is 1, n minus 1 divided by 6. And this is like a plus b and a minus b, we get a square minus b square, that is n square minus 1 square is 1, divided by 6 into 2 is 12. So this is the variance of this distribution. And here standard deviation, to calculate standard deviation of x, we know it is the positive square root of variance of x, so here you will get the answer under root of n square minus 1 by 12. So in this lecture we have studied first is BMF of this distribution, discrete uniform distribution, that is probability of x is equal to x is 1 by n, x takes values 1, 2 dash up to n. Then we calculate the mean of this distribution, that we get the n plus 1 by 2. Then we calculate variance of this distribution, that we get the n square minus 1 by 10. And then last we calculate standard deviation of this distribution, that is under root of n square minus 1 by 12. So these are the 5 important terms we have studied about this distribution. Thank you for watching.